But no, I don't think I've changed anything. Okay, YouTube's up. Okay, I've been remiss in my linear algebra-ing, and I've had this problem on the docket for, I'm gonna guess 3 weeks now. Probably your first officially. Ooh, I don't know. Uh, Third apparently. We also got to check Obi-Wan Pez though, right? Oh, I don't even know my own commands. Oh hey, and one over there. Hey, Jerry Agor, how's it going? Welcome in. Okay. Suppose ax equals lambda x. If lambda equals 0, then x is in the null space. Yes, if lambda is not 0, then x is in the column space. Also yes. Yeah, okay. Those space have dimensions n minus r plus r equals n. So why doesn't every square matrix have n linearly independent eigenvectors? This is the part where I'm like losing the thread. This isn't the first time that I've attempted this question. I assume it's because you can have a repeated eigenvalue. That's what my mind is telling me. What's right? I guess that's what my body is telling me. I don't know if that's what my mind is telling me. And Jerry, if you have a question, feel free to let me know. Space set of vectors that always gets you 0, right? And x here are the columns that don't change under A's linear transformation. I don't know why I had that written. They might change in magnitude, but they definitely don't change direction. Well, x is a non-zero vector. The 0, since 0, yeah. Hey, Jasu. Now, uh, I never figured out the answer to this question, and I got distracted doing physics to actually solve it for myself. I had this thing, I had this question pasted into this file for like weeks now, I think. but I've been constantly getting distracted from it. Right now, my gut is telling me it's because you can have repeated eigenvalues. But I'm not that confident in that yet. Thank you, Jesu. Yep. Isn't it in zero? It is zero. X is in the null space. And it isn't zero. X in the column space. The necessary conditions to having eigenvectors. I mean, you need distinct eigenvalues for each one. Well, actually, that's where I get confused with eigenvectors and eigenvalues. I think each you can't have two eigenvectors from one eigenvalue, I think. Um, Man, my linear algebra feels rusty. I've been spending so much time thinking about physics. Around a lot of this about like projection matrices that this is mentioning. It's not that important to this here, though. I've been on the dark side, yeah, with physics. I have been. Oh wait, join us. Yeah. See, even in linear algebra, they're shoehorning in physics. Yep. And Lux, I'm at the very end of chapter 3, and that's getting a little crazy with the Lagrangian. That's true. Yeah, Jesu is a chemist. I feel like that's even darker of a place to be than physics. Hey, Cytos. Okay, I was thinking my final guess for your problem is that it's like a diamond, or like, it's like a rotated square with the diagonals being like one half away. But I'm still like weirded out by your problem. 5 pages behind me? Okay. I've been like rereading this section here down to like I guess like here, just trying to understand it all. I haven't gotten past this, but I'm nearly at the end. It gets really weird here. Lagrangians. You don't do any actual chemistry. So your department calls you a fake chemist? Oh no. That sucks. You're already, in the dark side of chemistry, but you don't even belong there apparently. Chapter on Euler-Lagrange equation in Warren's Red Mechanics text. I don't know Euler-Lagrange equation. Oh, apparently seen this before. Jerry Agor, thank you so much for the prime. Holy crap, I appreciate it. Oh, is this basically it? I assume this is just the Lagrange equation as far as the book calls it. Are you saying 3.39? Yeah, I mean, maybe Hartle just hates Euler and only credits Lagrange. But it does look to be the same. At some means, my research part of the physics department was referenced as part of physics known as the math department. Oh, wow. That makes sense. I remember you saying that like your research kind of all over the place. Thank you again for that, Jerry Igor. So I'm still trying to. I'm sure there's something more fundamental here that I'm not like recognizing. When is something an eigenvector of a matrix? When it doesn't change direction after being multiplied by a. It does have to be in the column space or the null space for that reason, right? Wouldn't make sense to. Well, wait. Yeah. Wouldn't make sense if it wasn't, right? Um, I don't see what the answer could be aside from you can have repeated eigenvalues. But I'm sure that I'm missing something here. Oh yeah, I associate uni with like Europe too. Sis was in the UK. Oh, that's awesome. Your family is like everywhere, Fembox, because like you're like from Australia, or like you spent time there too, right? I might just peep at the answer here. This is 6.226. Boo. I've been thinking of this problem for a long time. There's something in the wording of it that just like weirds me out. All right, peanut gallery. The null space and column space can overlap, so X could be in both. It may not be R independent. I mean, okay, the second part is basically what I was saying with having repeated eigenvalues, right? Your parents live in Australia still? Oh, nice. Okay. The null space and column space can overlap. Wait, why is that true? I know they're not orthogonal, right? Because the column space is orthogonal to the left null space, not the regular null space. What does it mean if something's in the null space and the column space? Okay, I guess X would be a vector that solves AX equals 0, and that column is somewhere inside the matrix. Okay, sure. Okay, yeah, so that's even less of a reason to boo me for looking at the answer. I had it right. I just wasn't sure. 27 might be interesting. The matrix square root. We didn't moo you. I'd rather be mooed. Reverse engineering methods, the answer is fine. Okay. Uh, matrix and lines. That's a really common counterexample for things, right? Or like just example to look at. And you're saying E1. I think that's E1, I hope, and not E0. Uh, so 0, 0 indeed. So that this is in the null space, and it's in the column space. Aha. Thank you, underscore. Calc theory, linear algebra going to be in my next class that I pick up? Like, for like a class you're going to do on Twitch, or you mean like a class that you're going to take? Oh yeah, underscore. Also, hi. Always nice to see you. Agonize of A. Teaching back in community college. Oh, did you get a job over in the UK, or are you coming back? Maybe I've been slacking on watching you. Oh, I see what you're saying now. If you hadn't moved. Okay, okay. I think those classes will both be pretty fun to teach. I think Calc 3 in general is just kind of fun. I mean, thinking that is what spawned the whole like physics thing in the first place. I just wanted to look for interesting ways to apply Calc 3. So I guess we should probably diagonalize A, right? They save us some work in getting the eigenvalues. If lambda equals 1, then for A, we get 4, 4, 4, 4. We're interested in the determinant. No, we're interested where it equals 0, right? Ooh. Yeah, it's like that. God, I'm so rusty on matrices. It's so bad, dude. It's only been like 2 weeks since I've done this. All US units share the same classes. Like in the UK, it's completely random. I mean, there's some subtle variations in classes here. Like discrete math, especially, is just kind of like a hodgepodge. But yeah, I can't say I know enough about UK classes to compare it with. They just have the. I've seen like a Danish friends classes, and they have pretty strange names for their math classes and strange like mixes of things. So which my vector calculus was stronger. Same. I'm hoping that Zach goes through with that multivariable analysis course, because I think that might help some at least. We have concepts of what is Calc 1 or Calc 2. Yeah, I mean, I feel like they tend to use like kind of general math words to describe their classes, and they include a variety of things. Like, or you might even call like analysis or something. Not as much as difficulty increased each semester. Okay. Um, oh, I always draw it backwards. Kasai looks like that. Does it? I don't remember. Hey Rex, Matt Salvar, yeah. Oh, I got Kasai forward. Okay, good. That's a first. How I remembered it is I took the way that I wanted to draw Kasai and I just reversed it. All this for matrix A. Lambda equals 9. Just cover something first, you write some meanings cover later, and vice versa. Fair. Ugh, what a terrible letter. UK teaches similar methods at the same time, regardless of affinity for type of math. Yeah, this is allegedly Kasai. it may be hard to tell, but at least that's what that's what I was taught to use for eigenvectors. Kassi. Wait. Oh yeah. Do I say Kassi or Kassi? I don't know. I don't remember how I was taught in my class. Work on my Klingon. We call this Kassin Ping. Kassin Ping. Oh yeah, you did say that, Jasu. What is, or you did ask that. What is the worst Greek letter and why is it Kasai? The resistor symbol. That's basically how I draw them. It's like, okay, do a little antenna and then 3. Yeah, I know it's supposed to be Shinping, like their leader's name. I can't remember. Xi Jin. Oh no, not that's Jinping. Jinping, I guess, would be something else completely. 1009. Oh, do I have to invert this? Oh no, the entire point is I shouldn't have to invert this, right? Or maybe it's kind of a waste of time to find x, because the entire point is that x doesn't change with powers. Oh yeah, I didn't need to do any of this. Drop your tongue out. Shinping? I feel so weird. Shinping. I don't know if that's better or worse, but hey, Indu Sharma, teach me differentiation. Can you give me an example of something that you would want to see? Um, okay, I think the maybe, I mean, I can claim those practice. I guess that's how I'll be optimistic. But I don't think I actually needed to find what these were. I can just keep them as x and x inverse, because I think we can just take the square root of what's inside there. um Presumably. I assume we're just taking the positive uh parts. What it's all about? I can talk about that, yeah. I assume B doesn't have a real matrix square root because of the -1 then? Just let me finish up this one thing and do. I assume it's actually like a plus or minus that I would really want there. I don't know if that... no, maybe it's just plus in this context. We told you that one time that girl looked at you and shockingly she pronounced her name right? I don't think I remember that. You can't do root -9, dummy. Oh, I'm gonna guess Shi Chow? That's how I would guess to pronounce that. Okay, so in Charm, you're asking what differentiation is all about. And so I'll kind of give you the brief idea of what it's about. So if I just take a relatively simple function that we've probably seen before, like a parabola, y uh y equals x squared, yeah. Xiqiang? That's my guess for that one then? Yeah. Okay, if I take a relatively simple problem like y equals x squared, um, the first thing that we need to hopefully agree on is that if I just kind of draw what we call a tangent line, which is a line that just barely touches the parabola at one point, um, the slope of this tangent line is the rate of change of this function at that point. So if it's changing at one rate here, if I go, I should have given myself some more room. It's changing a hell of a lot faster up here in this part of the parabola. That's like, it's steeper. And the reverse is also true. We're all the way down here at the bottom. There's a brief little instant where it's not changing at all. Right where we have a zero slope. And so the thing that differentiation gives us is we can find the slope of that tangent line, which is the rate of change, at any point on this parabola. So I'm just going to go ahead and take the derivative here, because I'm going to assume that you've already seen how to take a derivative. And just kind of asking like for some reinforcement here on the concepts. So if the derivative of y equals x squared, you get y prime, like an apostrophe, equals 2x, using the power rule. Girl 2.0, thank you for the follow. And hey, Geotish Tom, feel free to put your question there in chat if you want. Welcome in, Girl 2. Hope you're doing well. Said Z Xiang. See it on stream sometime? Yeah, I'll have to catch you. Her jaw hit the table. Yeah, I bet. And so we can kind of match up y prime equals 2x to the slope of the tangents on the parabola. So if I actually graph y equals 2x, it might look something like this. 2 plus 2 equals 4. Use a calculator. That's how I will prove it. Empire, how do you do long division? I could talk about that in a few minutes if you don't mind. And so the actual y values on this line are the slope of the tangents over here. And so right at x equals 0, we do indeed get a value of 0 for that slope, so that matches. And the further to the right we go on this line, the steeper, like the higher the y values get, and that's a reflection of the slopes getting steeper the further up we go on the parabola. And I didn't talk about it, but over here on the left, we do have negative slopes. It's decreasing. And so all the way out to the left, it gets very steep again in the negative direction. And the same is true here. The further left we go, the more negative we get. So if you know the derivative of a function in the graph, you can kind of construct what the original function could have looked like. Okay, we're getting a bunch of questions at once in the YouTube chat here. Uh, I guess I'll talk about long division, because Empire asked about it, and then Aman is asking about even and odd functions. Yeah, Mert, it looks like it. Setting your 11 standard, will surely have doubts. Can you comment it? Yeah, Giadashtam. If you have an actual question that's not 2 + 2, we can take a look at it. And Volatiro, just want to add before you ask a question, say I appreciate you. Thank you, thank you. Explain how we find horizontal and vertical asymptotes. Yeah, sure. Fourier transform. I know the basics of finding the Fourier transform. My knowledge of them isn't super deep. Yeah, I feel like the basic idea of what it means to differentiate a function. I'm kind of running out of time to go much deeper into it, but I hope that at least helps you out a bit. All right, guys, I'm gonna make a little cue here because I'm I'm not gonna be able to remember who's all asking what here. Empire wants to know about long division. Aman Kun wants to know about even and odd functions. Balatiro wants to know about horizontal and vertical asymptotes. And RW Rahman wants to know about Fourier transforms. If you have a specific example, feel free to let me know. Nithalon Odes, yeah, if you have a problem, you feel free to put it in there. I assume they mean just long division of regular numbers. Principle of least action, I don't know about that one, I don't think. I should actually ask that. So Empire, if you want to know about long division, do you just mean like with regular numbers? Like, do you want to see how to divide maybe I don't know. What's a decent one? 125 divided by 5? Oh yeah, okay. And OB's 643 over 31. We could try that one. I assume it's evil in some way. Permutation and combinations that have restrictions. That's kind of a that's one where it's really helpful to see an example. Yeah, if you can fit it there in YouTube. That'd be appreciated. I do have a Discord as well. Displacement time graph a sine function from 0 to 2 pi in velocity versus time and acceleration versus time. I assume they just mean like it's a normal. Also, hey, Fizzbuzz. I assume they just mean like a regular combinatorics word problem where like you have different arrangements, but certain ones aren't allowed. Okay. Empire, please say something in chat if you're still here and if you still want to talk about long division. If I don't hear from you, I'm just gonna skip to the next person. Thermostatic. I can put you on the list. The quick answer there is that you're going to want to take the derivatives and graph those. The derivative of displacement is velocity. The derivative of velocity is acceleration. Kubrick? Oh, hey. Thank you. Good luck to you too. Okay, I'm not hearing anything from Empire. How about thermostats? Sorry, Jatsu. Empire, if you're still here, just put something in chat so I know that you're still here. Oh, nice. But Valid Hero. We can probably do that one. Okay, and then we have another one from Gotham. Sorry if I'm saying that wrong. We've got a queue here going, so I won't be able to get to everyone immediately here. Written questions and faster than I can answer them. Okay. Naman, welcome in. Thank you for the I guess like interest. Okay, so I'm skipping over Empire unless I hear back from them that they're still here. Aman, even and odd functions, I hope you're still here. I'll just start explaining them. So I'll first give kind of the math explanation for what these are. An even function satisfy even functions satisfy this relationship that f of x is equal to f of negative x. And so an example of something that meets this is, say, x squared. The test here is that if f of x is equal to x squared, we should be able to replace all the x's with negative x and get the same thing back out. So f of negative x here is, in parentheses, negative x squared. And then when you square that negative, it goes away. So you just get x squared back. So because we are getting x squared in both situations here, we say the function is even. It passes the test. An example of a function that does not pass the test would be, let's say, x squared plus x. Because now when we look at f of negative x, we get negative x in parentheses squared plus in parentheses negative x. And so now, just like before, the negative x squared is fine, but this just becomes a minus x. That plus does not match that minus. We do not get the same thing back out. So we would say this function is not even. Even odd function, every function bring a sum of even odd functions. Yeah, Trumer. X cubed is odd, right? Valatiro. Abhinav, thank you for the kind words. I know some programming, Naman. I minored in computer science. It's not my forte though. Kubrick. That question looks really involved. I don't know that I'm able to do that one. Okay, and now for odd functions. Odd functions, it'll be a similar test, but we're expecting a different result. F of x, wait, am I stupid? It's f of negative x should equal negative f of x. Yeah, that's right. All right, see you, Kubrick. Thanks for the kind words, our error. And so an example that Valetiro put in chat earlier that we can look at for an example of an odd function is x cubed. So let's compare with the calc homework. You did it. 5 exercises, a couple of 2 parts. Looks I didn't like the person who sent the solutions one long pixelated photo. Oh god, syntax error. That's some shade right there. This is a different thing. So the negative sign out front here is the very important difference for an odd function. So now we have 2 things to find here. We need to find f of negative x and negative f of x. So starting with f of negative x, we get negative x in parentheses cubed, and I can rewrite this because negative 1 cubed is just negative 1. I can write this as negative x cubed and not worry about it. And now to find negative f of x, that just is sticking a negative sign out in front. So negative x cubed. So look, same thing. X cubed is indeed odd. I stream this hour Tuesday, Thursday, and Saturday. Although, you might need to turn it. I'm in America. Depending on your time zone, that might be more like Wednesday, Friday, Sunday, early in the morning for you. An example function that is not odd, we can actually use the same function from before. X squared plus x. F of negative x we found before as x squared minus x. And negative f of x is negative x squared minus x. So here, the negative here does not match the plus there, so we'd say it's not odd either. Or so we say the function isn't even or odd, and that's something that's perfectly possible. That's okay. It doesn't have to be even or odd. You have your IGCSEs in 6 days. You're cooked. Good luck. The last thing I'll say about even in odd functions is that there's a certain symmetry that these functions have when you graph them. So an example of an even function we were just looking at before would be x squared. The symmetry that even functions have is the left half and the right half like match each other. Like this part here matches that part here. You'd say it's I guess symmetric about the y-axis. Like that's the line of symmetry there. And then for an odd function, they have a different type of symmetry. So looking at y equals x cubed. This one, still about the y-axis, except we have it like mirrored now, it's flipped. This positive part up here flips down and looks just like the negative part down there. Tyler, 2 places at once. Nice. Thanks for being here. Hey, Lucas. And so that's the visually symmetry. Odd functions are rotationally symmetric about the origin, or dual flipped across each axis. Oh yeah, so you could think of it as like, for even, you could think of it as taking the right part of the function and flipping it to the left. An odd function, you would take one half of it, flip it left, but then also flip it down. It's like two flips. And so yeah, as Mert says too, you can think of it as symmetric about the origin rather than a line. Okay, so that's what I have to say about even and odd functions. I still haven't seen anything from Empire, so I'm just gonna, unless I happen to pipe up in chat, I'm going to just erase these. Rotate your hands, that's fun. Let me shift these up. Okay, so I'm just gonna put a little dash for those being done. So okay, now we're on Valatira with horizontal and vertical asymptotes and permutation and combinations. Oh no. Oh, I mean, that's bugging you. A greater than 2, A is an element of n, 18 positive integers. I can try that one, Abhinav. That's getting a little, or I'm not sure if I'll be able to do it, but I can put you in the list and try to think about it when the time comes. Can't make any promises on this one though. The software I'm using is called Journal++. Hey, Mohammed. Haven't seen you a bit. Hope you're doing well. The answer is BD, apparently. Okay. For me, it's nearly 2 in the afternoon. To prove of y in a rising slope, if x1 is less than x2, f of x1 is less than f of x2. I mean, that's... it looks obvious, but it's good to be able to put stuff like that into like math language. Cook. Oh my god, I'm on such high alert with YouTube for trolls, and I'm like, oh my god, who is this? And then I look at the username, and it's like, oh, of course it's Cook. I'll read it loud for the benefit of people on Twitch. I heard Don saves money on toilet paper by instead just waffle stomping all his poops down the drain and then washing up with a shower. He even told me it saves him a trip to the gym since the waffle stomping was a scam exercise. That's Professor of Physics, everyone. Ugh. Okay, horizontal and vertical asymptotes. So, Volatiro, I'm just going to make up a function to look at unless you want to suggest one. Uh, Dr. Cook, we were just in voice two Saturdays ago for the uh general relativity reading group. He used to stream. He hasn't it in a while though. He likes to go into the YouTube chat and participate in the trolling. So sometimes formalize just means like to prove basically. Did I ever play Roblox? I played it a lot as a kid. I haven't played it. I haven't touched it in like 10 years at least. No, more than 10 years, like 15. How old am I? Yeah, at least 15. Um, 32? No, I'm 28. Okay, on top I'll put x squared plus 2x plus 1. On the bottom I'll put x minus 3 times x plus 1. Let's look at... oh no, okay, you have one you want to look at. Follow hero. Let's do that instead. Hey, Edison. Rob, it's nearly 2 in the afternoon here. Oh, this looks even harder? Here's how I know, Cook. I have a problem. I just can't help myself. Coefficient properties of binomial theorem. I only know very basic ones. No, I have zero interest in playing Roblox. How do I get by? Like for money? Or what do you mean? Matrices? Yeah, like if you're talking about like a matrix equation, yeah. Right now I'm living off savings. I used to have an office job that paid very well, and I'm living off savings from that. Okay, so thinking about this function, we want to find vertical and horizontal asymptotes. You can type it there in chat, or you can put screenshots in my Discord. Okay, so the first thing to do when you see a function like this is I guess we want to kind of play with it and see if there's any like cancellations we can get, because sometimes or like, you know, if we get a cancellation, that changes how we graph this function. Let's see what's problem turning children's coding time into near nil compensation. A very popular well-earning mod. Yeah. That's true. So the top, I kind of engineered it so we would have a cancellation. This turns into x plus 1 squared if you factor that. And so we do get a cancellation here, as Rob says. So the x plus 1 cancels, so this function is going to it's going to be nearly, but not exactly, identical to x plus 1 over x minus 3. And I say nearly because we're asking about the original function. As soon as we have this situation, we're never allowed to plug in x equals -1 or +3. But even though the thing preventing us from plugging in -1 goes away eventually, we still have that restriction. We cannot let x equals -1. Oh my god. Cook. But we can now look at this function and have a little bit of an easier time here, relative to otherwise. Edison, I can put you in queue, but we've got a... this is what the queue is looking like right now. I'm currently on the third person, so I should probably speed this up. Oh, I'm at Abhinav. You put a second question in there. I glazed over that. I can't promise you an answer to either either of your questions, but I always put them down here. Yeah, because today's just a day where YouTube is pushing my stream. I think it's pretty busy over the YouTube chat. Okay. So now looking at this function, we just have one. So the vertical asymptotes happen when you divide by 0. And so when we looked at the original function, we get 0 when x equals 3 from that part there. Or when x equals -1 from that part there. But as we showed, we don't need to worry as much about the -1 because it cancels out. So when I go to actually plot this, 1, 2, 3, we're just gonna have one true vertical asymptote at x equals 3. And so now for horizontal asymptotes, if x plus 1 wasn't canceled out, I would draw a second dotted line over here at -1. And that'll be another vertical asymptote. And like these vertical asymptotes, they're like jail bars. You cannot cross them. Horizontal asymptotes are not like that. They're not really true asymptotes. And so the way that you think about horizontal asymptotes, it kind of varies by the class. I think the way that it's normally taught is you look at the degree of the thing on top. This is just a linear thing, so it's degree 1. And you look at the degree on the bottom, which is also 1. And when the degrees are equal, the rule is we take the leading coefficients. So x plus 1 over x minus 3. I maybe could have chosen a better example, but we like, there's still an invisible 1 in front of this x, even if we don't draw it, both of them. And so the horizontal asymptote will be 1 over 1, like this one over that one. That'll be y equals that. So it's just y equals 1. And so yeah, that would have been a better example to choose, but I'm just going to stick with this for now. Abrar. Oh yeah, I'm sorry. I'm not familiar with GCSE. So that means that we get our horizontal asymptote that looks like this at 1. But remember, like, this isn't a hard and fast rule. It's more of a guideline for how you draw your function. And And I should probably briefly say a better example for this rule would be like a different, if you had 2x plus 3 over 3x minus 5, this would be a better example to take the leading coefficients because it's a little easier to see be y equals 2 over 3. Sounds good, Schrodinger. Oh shoot, when did you initially type in chat so I can put you in queue in the right spot? I'm scrolling up right now. Okay, right around when Abhinav asked their question. I think before Edison. God, I'm right. The queue was getting too long. Okay, there. I need to get through these a bit faster. And so these are the guidelines for how we graph it. The final thing to do is to actually graph it. And so these types of functions tend to like blow up to positive or minus infinity around the vertical asymptotes. Like they'll get like they'll go straight up or straight down. And so I'm just going to kind of draw the approximate trends here. And actually, I think it's even easier just to plug in like test points. Like plug in x equals 4 to get whatever point is there. It's going to be 5 over 1 is just 5. So it's going to be like somewhere up here. And just from our guidelines now, we know it's going to go, it kind of has to go up. Otherwise, if it went down, we cross over our horizontal asymptote. So it's going to go up in that direction and then come back down and go along the horizontal asymptote. And we could try plugging in, say, x equals 2, but these functions are always symmetric in some way, so I just know that it's going to look something, it's going to be a mirror image of this. So it's going to look something like that. Oh, and the restriction. We still can't allow x equals -1. And how we represent that here is we do an open dot right at -1. We still can't plug that in. So we kind of like, we put that dot there to signify that. Oh yeah, shorts are good for views. I don't know that they're good for like long-term growth, but shorts can get a lot of views. I was basically doing human resources in my office job. Oh yeah, so Valetero, you asked earlier about what would be the horizontal asymptote for a particular example. Sorry, I missed that. X minus 2, x minus 3, x minus 4. What I would say here is that if you were to multiply, we can save ourselves a lot of work here. We don't have to multiply this out. We can know that if we did multiply this out, on top, we would have a quadratic, so degree 2. On the bottom, we would also have a quadratic, so that's going to be degree 2. And so the degrees are equal, so we just care about the leading coefficients. And so we get the leading coefficient for the top, we know it's going to come from doing this x times that x there, and that's just x squared. And then I'm just going to do plus like dot dot dot. We don't have to care what the rest of it looks like. On the bottom, same thing. The leading coefficient will come from that x times that x. So that becomes x squared plus something that we don't even care about. And now we can do the same leading coefficient trick. There's a 1 there, a 1 there. So I'd say this also has a horizontal asymptote of y equals 1. If the degrees aren't equal, then there's two separate cases. Let's say the degree on top is bigger, x cubed plus x squared plus x plus 1. And let's say the degree on bottom is 2, so x squared plus 2x minus 3. Here, you would think of this, the degree on top is bigger. I call it top-heavy. If you think about it, when we plug in very big numbers in for x, which is what we care about for horizontal asymptotes, we pretend like we're plugging in very big numbers. This cubed is going to grow way faster than that squared. So for a very big number, it's going to look a lot like the top and not like the bottom. And the top just blows up to infinity. So, this one wouldn't have a horizontal asymptote. Goes to positive or negative infinity. Like the graph is going to like blow up somewhere like that. The other case is going to be a bottom heavy function, or the bottom has a bigger degree. So let's say x minus 3 over x squared plus 5 minus 4. This squared matters a hell of a lot more than that x. And if you divide by a very big number, you're going to 0. You get a very small number. And so this will always have a horizontal asymptote with y equals 0. And there are slant asymptotes too, which Dr. Cook put an example of one, I think. Had quite a lot of dislikes on a few. I mean, I think that's just YouTube. People are always going to hit dislike on stuff. I wouldn't care about those personally. And sorry, guys, there have been some things in YouTube chat that have kind of like gone by and I have a hard time keeping up with everything that's being said. There's only like so much I can do here. Cook said x squared plus 1 over x has slant asymptotes. I got y equals 0. Oh, okay, yeah, Dojo, this is the same thing I see. I got y equals 0. It's more just it's kind of an intuition thing. If you plug in a very large value of x into this here, the squared matters way more than the x to the 1. So we're going to be dividing by this is basically a small number over a very big number. And when you divide by a very big number, you just get a very small number. Thank you for the kind words, Abhinav. And so that's why it just always goes to y equals 0. You know what? There is a this second case that I put here has a bit of a subtlety though, because it could have a slant asymptote. There's no horizontal asymptote. There could be a slant asymptote, and that's what this example has here. Shoot. Oh my god, Cook, why are you on this? Chess start, welcome in. JC is just feeling trolly. This is a math help live stream. This is the queue of questions is right here as it stands right now. I really need to pick up the pace. Hey, color cone. Yeah, welcome in. I'm 28. Abhinav. John Reed, I like your style. XCF, I have a bachelor's in applied math, and so like if it's like a first or second year undergraduate question and below, I can usually help with. John's been around in the YouTube chat before. Sounds good. Volunteer. Do you want to talk about your combinatorics question too? Yeah. Okay. Let's. I. Wait. That's you, Fembox? I need confirmation from Fembox on Twitch. I I am stunned. I never knew that was Fembox. Over the chat, there's someone who's like come by the YouTube chat named John Reed, and I just assumed that was just a person who liked math. Well, it could also be that, but apparently it's also Fembox. Find the number of ways in which a committee of 6 people can be chosen from 6 men, 8 women, if it must include 3 men and 3 women. Okay, so the committee has 6 people. The first 3 slots let's just say these are the men's slots. And the second 3 slots are the women. I think how we think about this question is for the first slot, for men, we have 6 men to choose from. Then we've chosen 1, so now we only have 5 choices and then 4 choices. And now once we get to the women's slots, we now have 8 choices, then 7 choices, then 6 choices. Ladies first? Oh, you're right. That's not very chivalrous of me. Ladies first. There you go. And now you just need to wait for one of the cities to go on here. And so now you just multiply across the way here. Whatever that number comes out to be. Would the n choose our way be 8 choose 6 times 6 choose 3? I think these are equivalent. Yeah, they should be equivalent, right? No? No. Oh wait, I might be wrong here. This way up here, it might be permutations. I might be overcounting. I think it'd be. Sorry, 8 choose 3, not 8 choose 6. Yeah, I think what I'm doing wrong here is what I've done here is order matters, and order shouldn't matter. So I'm going to imagine that you would end up dividing each of these by 3. I'm not confident in that, but I think just even forgetting about this entirely is maybe even better here, because order doesn't matter. I think that maybe some other thing about it is saying we have 8 women total and we're choosing 3. And then we have 6 men total and we're choosing 3 of them. And we multiply them together. For a reason that I have trouble putting into words. So I'm not that good with combinations. This just gets us every combination of men and women, and I'm having a hard time putting into words why. But this is something we can plug into a calculator and actually find. 1120, apparently. Yeah, I think it's how you should think about that. It might combination or like my combinatorics isn't the strongest. Oh God, her sheet. If I'm saying that right. Those types of questions I like fill me with dread because they're so weird. Um, I have a lot of questions I need to get through first, though. I'm sorry. RW Rahman, are you still here? Want to talk about Fourier transforms? All right, Suplo, you are here. Okay, nice. Thank you so much for your patience. So basically, what a Fourier transform does is if you have a periodic function, you can always express it in terms of like a sum of sines and cosines. Good night, Volatiro. And there's a formula you can use to find how that looks like. Ugh. Here we go. This is how this is the general Fourier series, and it's already kind of given to you. Like um L defines the width of the interval that you're like periodic over, and all you need to do is find a0, an, and bn. That's the only real task when you have a function you want to find its Fourier series. And there's just a formula for these. It's right here. Transform is the generalization. Um, I mean, once you found that series, is that not the transform? Why do we take the transform? How does it help over the periodic function? Um, it helps because sines and cosines are just known to be nice. Like we know how to deal with them. Um, the function that it's coming from might be something that's really difficult to work with. And so like I know like in electrical engineering these get used a lot. And Harshi, I'm sorry, but I'm probably not gonna have time to look at that. The queue's gotten kind of long. I mean, this is the entire. I'm here in the queue. There's all this other stuff to get through, and like these questions aren't all easy. Um, and so sometimes the Fourier series just kind of springs out as the solution. Um, as Collarcone says, like the heat equation that like a Fourier series just is the solution to it. Heat equation. Will be a good thing to look at. So like this is it's called a partial differential equation. If you haven't seen this before, I might be getting a little too ahead of myself, but there are things called partial differential equations, and a Fourier series can solve them. Ane, it's looking less likely before I'm gonna run out of time on the stream. We've got a pretty long queue. And so yeah, this is I think where they actually like came from trying to solve this partial differential equation here. And so you can also use these for approximations. Like the true Fourier series is an infinite series, but you can take just say 100 terms and get something that's like a lot more manageable to work with. The transform doesn't require periodicity, really. That's interesting to hear about. So, like I feel like I should make the disclaimer again that I've only just kind of scratched the surface of these things, so I don't know them that in depth. Um, but yeah, they can come up as a way to like just like approximate. Like normally when there's a series, it's often a good way to approximate certain types of functions. Fourier series and Taylor series and where they came from. Fourier series we're talking about a little bit right now. Taylor series is kind of a different like topic, and I need to put that in queue, and I don't know that I'm actually going to be able to get to it. So I'm sorry, Ane. Um, I can link you to a page that talks about them at least, but I just am not going to have time to get to everyone's questions if I keep adding on to the queue. Um, so that is you, Fembox? It went through, yeah. Abrar, do we need to include more terms in the questions that we asked for in like a Fourier series, or what do you mean, Abrar? Oh, using complex variables. Interesting. That's probably this right here. Or is that the inverse? I don't know. So yeah, I'm running out of things to I guess say about this RW Ramon, but if you want to ask another specific question, I can try to answer it or see if someone in chat can answer it. I can also link you to this page that I'm looking at here. But But yeah, let me know. If not, I'm gonna move on pretty soon here. Hey, Prem. All right, sounds good. I'm gonna start looking at the next one then. Okay. Thermostatic a while ago asked about if you have a sine function from 0 to 2 pi that represents displacement, how do you find velocity versus time and acceleration versus time? I'm not sure if thermostatic is still here, but maybe they'll check the recording, and so I'll try and go through it here. Time, displacement. Now sine, I'm going to put marks at pi over 2, pi, 3 pi over 2, and 2 pi. And on the vertical axes, I'll put -1 and 1. So sine looks like this over 0 to 2 pi. Displacement is equal to sine of t. For 0 is less than or equal to t is less than or equal to 2 pi. Yeah, today's just one of the days that YouTube is popping. I don't really know how to predict it. How do we take gamma functions of non-integers? Prem, I'm sorry, I'm not sure. I don't think I'm gonna have time. I'm staring on the barrel of a queue that's this long right now, and right now I'm here in the queue, and there's quite a few more questions to get through. The gamma function is an interesting thing. I don't know it that well for myself though anyway. Okay, and so to get the velocity versus time graph, I can think about it in two different ways. Let's put the same scale. Oh, it's great to hear, Abrar. And you're asking for functions? I'm not sure for which functions you mean, Abrar, I'm sorry. The math you learned from grade 1 to 12, do you think you could learn it quicker if you decide to study it yourself later in life, rather than the weight school makes you have? Yeah, for some people, yes. For other people, no. I think it depends on the person. There's people who come by the stream who are self-studying math and getting through it quicker than they would in a school. I think some people like benefit from the structure of school, but if you're the type of person who can be like self-motivated and about stuff for yourself, then I think it's just as valid and potentially faster. It's a Fourier series at 13. Wow, nice, Prim. Okay, so for velocity versus time, if you know derivatives like calculus, you can just know that velocity is equal to cosine of t. But if you don't know that, what we need to do is look at the tangent lines to our previous graph, because say like that tangent line right there, it just hits the graph at one place. The rate of change, and this is the rate of change of displacement. And the rate of change of displacement is just velocity. And so right at the very start here, we're going to start with a slope of 1 for our tangent line. So for velocity, I'm going to graph 1 right at 0. Hey, Foodie. And as we go from 0 to pi over 2, it gradually levels off and gets to 0 right at the top. So momentarily, it's not moving there. So I'm going to go kind of slope down to 0 here. And then as we move past that peak, we're getting negative velocities. Right at pi, we're going to hit a velocity of -1. So then I'm going to go down to -1 there. And then once we hit pi, we start to level off again and go back up towards 0. Sorry, up to 3 pi over 2, we level off towards 0 velocity, and then our velocity turns positive again. These slopes are positive all the way up to 1. And that looks just like the graph of cosine, so you could say there that it's cosine. The question I'm working on is they're given a graph that sine of t represents displacement over 0 to 2 pi. How do you get the acceleration and velocity graphs? And so for acceleration, it's going to be the exact same process. We just do it with the velocity graph. And so I'm going to go through this one a bit quicker because the queue is so long. 1, 2, 3, 4. Yeah, exactly. If you know your calculus, you can just look at this and take the derivative. It's going to end up being minus sine of t. But if you don't know calculus, then we can do the same exercise here. So here we start with 0 slope. So let's put a point here at 0. And then immediately the velocity is going down. Like the slope of the tangents are down. So we're going to go into the negatives. Why is this weird? No, yeah, that's fine. We're gonna go into negatives, and then after pi over 2, we're gonna start to turn back around and go up towards 0, right at pi. And then we're still going up after pi. So we hit a peak, and then we come back down. And so that's negative sign. Foodie, I'm sorry. I have a queue of questions going, and it's already gotten a little bit out of hand. I'm not sure if I'll be able to get through all of these in the first place. If I can get through this queue and I still have energy to do questions, I'll take some more. But these people have already been waiting for a long time, so I'm trying to get through these questions first. So Guatemalan IITM. Engineer needs to visit a factory for exactly 4 days during the first 15 days a month. This is another combinatorics question. Convert? I don't remember what said convert. Okay. How can we think about this? Oh, negation might be a good idea, yeah. So, I think I like that idea, Ishan, yeah. The total ways, ignoring the 2 consecutive day rule, is just going to be the simple 15 choose 4, right? All right, see ya, Abhinav. I'm sorry I didn't get a chance to get to your question before you had to leave. But I think people are talking to you about them. Um, and so now we can find all the scenarios that don't work and subtract them off the total. And so I guess the first, how should we think about this? This actually isn't simple either. do it as just quit the selected days. Then we have 11 terms for days as linear order. Then we want to put our 4 selected days to the gaps. Okay, Central. I don't understand what you're saying there, Mert. Am I winning? I don't know. I'm about to get wrecked by a problem that I should be able to solve, I think. Complete all of math or complete this problem? All math? Okay, I'll let you know. Yeah, yeah. Fair enough, yeah. Cannot select one gap for 2 selected days. 1, 2, 3, 4 days. It's from JE Advanced. Okay. Ugh. I don't think I've ever easily solved a JE Advanced question. I usually prefer just not to do them because they are so needlessly difficult. One, two, two, three, three, four. I noticed those are numbers, Jess. Two people pay you the yeah. Thank you, Central. Um, I'm trying to follow both. I'm trying to notice things Jess wants me to notice, and I'm trying to follow Mert's train of thought, and I'm failing at both of those. I don't understand this thing with the gaps. I don't know what I'm supposed to notice with those pairs of numbers. It makes sense to both of you, up to people in YouTube chat, though. I haven't seen this gap thing before, I don't think. It was this way of thinking about it. And I know, Mer. I'm sorry. I appreciate you trying. I haven't seen this before. Like, I can kind of imagine that, like, if I choose this day here, that's going to block off that day and that day. And I assume the argument is I assume the gaps have something to do with blocking off those other two days, but Langland's program or QFT, I don't know what Langland's program is. Same as selecting 4 numbers from 1 through 14, which are not consecutive. Okay, yeah, I was wondering about the 14. And I'm sorry, Jesu, I don't know what you want me to notice with the 4 days. Because I'm just stressed out by the amount of queue. If you want to help me, please just be more direct. I'm not trying to learn from this. I'm trying to help people. When I'm doing the self-studying for algebra, feel free to be indirect. But if you want to follow your line of logic, I just would rather you be direct with me. 15 choose 4. I think it's the total ways if we don't have the rule that no two visits take place on consecutive days. Well, yeah, so I know the total thing is 15 choose 4 OB. I don't know how to deal with the rule we have. Hey, ND Vines. Lucas, this is the thing I often do with combinatorics questions. I didn't draw it out fully, but if in this question we have 15 total days to worry about, and it's often helpful to like make a slot for each of those like 15 days. So, and think about like where you can place certain things. I don't want to draw all 15 slots for this problem. Um, yeah, I'm just gonna like, I'm just Googling this because it'd be nice to see this gap thing actually explained out. That's a very short answer. They're saying it's the same as 12 choose 4. And Jasu gets the same. Mm. Is this gonna try to make me pay? I feel like it is. Oh, I don't want to watch a video. Oh, hey. So now, do I answer physics questions? Kind of, if it's something that's relatively, like, basic. Like mechanics or electricity and magnetism. Oh, Mert. I think I see it now. Okay, I think I've seen that method before. I wasn't connecting the dots of using that. Um, or like we're like if we have okay 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 we would think about putting the days in between the slots. But presumably we need to take out some of these days. There's 11 numbers, rest which is unselected. Because we're choosing four things, we erase four of these for some reason. I'm not clear on my way of the 11 elements, but I think I'm just gonna leave this. The answer is 12, choose 4. Um, I'm just not familiar enough with like this technique to be able to figure it out for myself quickly enough. But if the person does come back and check it, they at least see what Mert's putting in the YouTube chat, and hopefully that will make sense. um, thank you, Mert, for trying with that, or like trying to help me understand it. Abhinav put in 2 questions. Abhinav did have to leave. I prompted at least look at these. I don't know that I can solve either of them. Hey, Anju. You saw the first one in the YouTube chat? Oh, good. Thank you for that, Mert. I have a bachelor's in applied math, Abrar. I graduated like 7 years ago now. I'm just gonna so for the first question, I'm just gonna read it and try to understand what it's saying. But if I've already got help with it, then I'm not gonna stress about it. A greater than 2, A is an element of n. There are 18 positive integers satisfying this inequality. Then A is composite, A is odd, A is greater than 8, D lies in the A lies in the interval 311. You don't know why you come here. I don't know either, but thank you for coming here. It's a weird one. Is that like a Vietas thing? Where it's putting x greater than 0 for cases, just in positive integers. Okay, yeah. A less than x less than 2a. There's 18 positive integers x that satisfy the inequality. Mm. 0 less than x less than a. So what's happening? Like, x minus a, x minus 2a, x minus a squared. If we're looking at that case, this is negative, that's negative. A is greater than 2. So all three of these are negative, right? Uh, Schrombach, yeah, I think it's just natural numbers between 3 and 11 is what that means, not like the continuous interval. Foodie, probably not. The key was, or it's too long already. Or I like if I can get through the queue, I'll ask whoever at the time like has more questions if they're still here. But I I I I I, I want to get through the queue as I promised it. Basically, Lucas, yeah. Oops, I scrolled down too far. If a is greater than 2, then a minus 2 is greater than 0. Squared is greater than 2a. Yeah, Fembox, I agree. Um, I should be again in 2 days, but the first 2 hours of that stream is going to be physics, and then I'll see whoever has a math question. But I don't stream every day, no. Um, I I would say I don't know we do the first one, but if I've already got help with it, then I think I'd rather just move on with respect to how big or how full the queue is. What's up with Abhinav's second one? I was just looking at the first one, but apparently they've already gotten help with that from Mert. I was trying to understand it for myself, but it's too complicated for me to do right now. At least this is the second one they asked, and I'm just gonna read right now. X a minus x less than y a minus y for all x y is 0 less than x less than I less than 1. Same is true options now. Uh, if and only if a is greater than or equal to 2, if and only if a greater than 2. Um, well, I guess checking a equals 2 seems like a good thing given the options. It's like, geez. What? Dude, I can't write. My brain is fading, apparently. 0 less than x less than y less than 1. Um, Well, yeah, they're saying for all, so we could just choose numbers for x and y. Oh, you're factoring. Really? Is that what we would want to do, Finbox? If y is greater than x, that's always negative. So the only way you can mess it up is if a... Oh yeah, I mean, wouldn't 2 be the worst thing to plug in here? Because that's guaranteeing that it's negative. Y minus x... Oh, you're right, Jed. Thank you. So it's... Okay. So that would narrow down to a and b then. Because y and x are at best really close to 1. Um, I think it's... I feel like it's just a, though. No, 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 no. I'm sorry. Is it? 2 itself should be fine, yeah? Yeah, I think that just answers, like, I think it's just a that we can tell based off that fact from that Fembox. Are we sure the factorization? I was just trusting Fembox. We can check it for ourselves. I don't know. Oh, is this like a grouping thing? Oh, Fembox grouped this, I think. Uh, oh wait, I'm getting a different factoring though, right? No, this is the same factoring. Okay, so yeah, I'm pretty sure Fembox is factoring there. I get to the same thing. Um, and so yeah, I think it should just be option A. I should compress this work. Okay, yeah. Why? Why is it A? Because if 0 is less than x is less than y is less than 1, then y plus x at best can be 2, like really close to 2, but not quite. So if a is greater than or equal to 2, you're guaranteed this entire thing is negative, and you're always guaranteed that y minus x is positive. Hey, Abdul. You drew a picture of them? It's the picture feels weird when there's an A involved. I don't know how that works. It probably does work. My brain is just like slowly fading right now. Um, let's look at Schrodinger's matrix. Should picture the inequality. Oh, okay. Oh God. What is this? Does A have convenient powers? A can't be two? Why can't does A equal two not work? It seemed like it would to me. Oh, I didn't see that you'd even responded to that one. Thank you for doing that. Doing a Dunford decomposition, I never heard of that. Then binomial formula? Jess is saying it does work. Yeah, I think it does work. Is that what the Dunford decomposition is? Just removing the diagonal? Oh, interesting. Usually it's more complicated. Okay. Uh, Naman, there's a couple people who'll be ahead of you in line, but if you want to post a question in the Discord, um, put it like here in Math Homework Help is the best place. Just like go here and then make a new post. Um, the two matrices commute, so you can apply interesting. So if I called like that one B and that one C, I mean, do we want to find or like I guess I can see how like B plus C to the n should have the binomial formula be applicable. We need to sum these up though, don't we? Oh, yeah, because I guess the point. is that, like, I should just call it I. What am I saying? And that'll be B. Like this I to the, like, it doesn't even matter. It's not going to change anything with the multiplications. We can just ignore it. There's still a lot of computations here, though, right? Because wouldn't I have to do each power of A individually here? B cubed is 0. Should I try to do this mentally? Squaring B? That column times that row, 0. That 0. That times that, get a 1. That times that, 0. Anything on that column should be 0. That times that should be 0. That times that, 0. That's all zeros. Okay, I think that's B squared. Oh, I get it. And yeah, if B cubed is all zeros. Aha. Okay, then any power B after that is surely all zeros. You're getting 20 10 bucks? Okay. I guess let me verify that B cubed is 0. I take this and multiply that. B to the, oh yeah, thank you. I guess it doesn't matter which goes first, right? 0, 0. Well, I guess these first two columns are forced to be 0 because those two columns are 0. Same the last row 0 because that last row is 0. Oh, did you just like Wolfram and Jed? I mean, I allow it. I think people probably say no. Okay, yeah, B cubed is indeed 0. So we can multiply all the b's we want into after that, but it'll always be 0. Okay. So do we only have different binomial coefficients to worry about then? Is that a differential equation, Yetharth? It is? Okay. What's the queue looking like right now? It's just this one, then Edison, then whatever is posted in the Discord. Um, my queue is too long. We're gonna get rid of this even odd function thing. Okay, I'm adding on to the queue since we're towards the end. The real NRN is the person posted in Discord. I think that's Naman in YouTube. And then Yatharth, you'll go after. So right now I'm right here in queue. And then Yatharth, you're getting added down here. Yeah, Obi. It looks like the differential equation is second order constant coefficient non-homogeneous. Y prime. I guess that's plus y. I think you're using the big D notation, which is always good for a giggle. But I'm assuming that your question is basically that in terms that I'm familiar with. Yatharth wrote plus D plus 1 equal cosine 2x. I assume these two things are equivalent, though. Everyone loves the big. um, what am I doing here now? I'm saying, you know how to solve the. It's not too much harder when the coefficients are constant. We'll see when the constants are coefficient. Um, these binomial coefficients are kind of annoying, aren't they? Triambach is also column 2020. Oh, are they always the same? Maybe that's the. They're always the same. Um, A itself is just that. A squared. Well, okay, yeah, this is where we get into a pattern now. So for 2 through 20, it should all be the same. Is it? No, yeah, we need a formula like Triambach is saying. Hey, Toto. Some sins are fun. I assume we're gonna have 19 times k equals 0. Oh, why even do a summation? Oh, well. It's not as simple as I thought it'd be. Yeah, I'm just struggling with the n is always changing here. I'm trying to avoid the double summation. Thank you, Yatharth. Uh, Okay, we're going to get two choose, or no, k choose zero. No, k choose zero of b to the zero. Is that just I? No, sorry, b squared. The b squared. No, not b squared. No, it is b to the zero. Then I'm trying to do the b to the one separately over here. See, but like this is why it's getting weird in my head. This is why I'm slowing down. Like I. No, this is stupid now. This doesn't make sense. Cyclic quadrants? Oh, God. I didn't want to know. I don't know how you do this last part, guys. Oh, God. Toto, if you're going to spam that, I'm just going to time you out. Your CIEs are coming soon. This would help a lot. I haven't heard of CIEs, but good luck. All right, Toto. Come back another time. Oh, a birth the YouTube chat just started spamming stuff. OB non-homogeneous portion, undetermined coefficients. Okay, I'll try these out. That's always things. It's either that or variation of parameters. And variation of parameters is kind of a formula that I can never remember. That it is pretty classic YouTube chat. Yeah. Um. All right. I can't figure out how to bring that one home. I don't know how to write it more explicitly though. Oh, do I know how to write it more explicitly? You know, there's per variation parameter time we use it. Geometric sum? You can use that with matrices? Would like the eigenvalues need to be less than one? Integration to the actual devil? It sure can be. It's just, oh yeah, it is finite. Yeah. I don't know how to find powers of A more explicitly. To be honest, when I'm just doing like math help questions, I'd rather you just be more direct with me and not give me hints because I'm trying to get through a bunch of questions. Um, I honestly, I'd rather just move on because I can't figure it out for myself. Haley Hamilton? I forget how that works, but it seems like there's a way that you don't need that. Edison asked earlier about one-to-one versus onto. Um, it's always a weird thing to explain. I'm going by the queue, Naman. You'll be after this. I think you were after that. Oh, let me shut you out. Um, okay, so usually when we talk about this, we think of a function as having a domain and a range. Domain inputs and a range outputs. And we can say this with kind of variables as like f of x is equal to y. X is something in the domain, and y is something in the range. For how we normally are first introduced to functions, at least. And they sometimes use a different notation, like f maps like something to something, but I don't want to get into that right now. We often represent the domain as in range as just being like sets because they are just sets, and so I'll draw them as like circles that contain a bunch of things. These are normally numbers. They don't technically have to be, but they, for our purposes, we can just say that they're numbers. The range similarly is another set of numbers. So if it is, no worries. If the function is, I guess we can start with onto. Oh, god damn it. Okay. YouTube is getting degraded. Hide. Hide. How do people organize this stuff like this? Like, this is not the first time this has happened. Okay, I think I got everyone. Or so correctly, I wasn't reading it, or I wasn't like checking it that closely. Oh, is it like a time limit for typing in chat? That could help fix that murder. I didn't know that was a thing. I'll have to look into it. Thank you for suggesting that. Sounds good, Spetri. It's people who are saying Allahu Akbar. Like, I don't get why, but if you see a flood of account, or if you see someone like randomly posting that, they can just get hidden. Because I've seen like they've just like come in waves before, as they make new accounts or something. Aro, I graduated college like 7 years ago. I have a bachelor's in applied math. Um, oh, cool. It's still working for you, Spetri. Thank you. Hopefully they just don't show back up. Oh, thank you, Jed. I've had people be stubborn and keep showing back up, but we'll see how persistent those people are. Okay, so if a function is on 2, that means everything in the range gets hit at least once. There are no parts of the range that don't get mapped to. So like that element there could get mapped there. That one could get mapped to the same one. That one gets mapped over there. As long as everything on the right side is being pointed to, we're fine. Time for some order in here. Number theory? No, number theory is one of my least favorite parts of math. Which is kind of blasphemy, but that's how I feel. So now let's do the same type of setup here, but for on 2. Onto means that no two things in the domain go to the same thing in the range. So, hey, Enochian. So what happened, like with these two domains both being mapped to that range in the onto case is bad for 1-to-1. So actually, I'm gonna add a few more things into the range. So for 1-to-1, each of these arrows should point to a different thing in the range. If you point to the same thing twice, bad things are happening for being 1-to-1 at least. And I drew in some extra dots in the range to emphasize that it's okay that these 2 points here didn't get mapped to. We're not, if they were getting mapped to, we'd say it's onto, but it doesn't have to be. A function can be onto, it can be 1-to-1, it can be both, and it can be neither. Right? I'm pretty sure. A function both 1-to-1 and onto is bijective, right? Are trig functions considered many one? Trig functions like sine and cosine in particular are neither. The issue with sine and cosine is that they're definitely not onto because the range is stuck between 1 and -1. So we don't map to all the possible y values. And the issue for 1-to-1 is that there's actually infinitely many things. You hit the same y values infinitely many times. So you can draw like a horizontal line to test it for 1-to-1. And that would fail that horizontal line test. Yeah, sine and cosine are good examples for odd and even, but not 1-to-1 and onto. Function f from set A to set B is called onto. Yes, that's a good, like, more formal definition. Tangent though, well, tangent. I bet tangent is on too, I think. Oh yeah, I mean, I don't think that's obvious. You could restrict the domain of sine to make it 1-to-1. And that's the thing that you kind of have to do if you want to talk about inverse trig functions. That's why they have weird restrictions to get them to be one-to-one. Many-to-one? I don't know if that term really exists in math. I haven't heard of a function being called many-to-one. You would say just not one-to-one or not on two. Okay, Edison probably isn't here, but hopefully if he goes back, you'll see that. We're now on to Naman's question. You're asking about 18 specifically. Oh yeah, and I'd be happy to take a look at a differential equation in Boxer. I'm sure someone in chat would too. 1 over cosine x. That is the definition of secant x, yeah? Odd degree polynomials are onto. Yeah, they're onto. I'm looking at number 18 here. So the top one. Trish, why is the double derivative of y? It's just kind of a notation thing. There's no reason you couldn't define your own notation to look like that. That's a quick question, so I'm going to quickly address it. So Drish is asking, why is this the second derivative of y? And the answer is, it's because we all say so. It's not a particularly good reason. There is a difference between this, the second derivative of y, and the first derivative squared, which could get confused with the thing that you're saying, Drish. The other reason is that the real thing that makes it the derivative is the d by dx. Like, it's also common to write it like this, like d by dx of y, where d by dx is an operator, like the derivative with respect to x. And so that's usually like, we're not squaring the function y. So that's basically the answer. Like, we're not squaring y. We're saying this is like we're taking two derivatives of y. Like, this is how this notation unpacks as. Yeah. No worries, Trish. Infinity basically means the same as undefined. Like, it's kind of you're not supposed to plug in things that give you infinity in the first place. Nancy Morris, thank you for the follow. Okay, let's read 18 here. A polynomial p of x satisfies the relation x minus 16 times p times 2x equals 16 times x minus 1 p of x? Or p of 2x, not p times 2x. Okay. Let p of 7 equal 135, then Aman, please just post your question once. That's perfectly fine. You don't need to keep on posting it. One over 0 and 0 over 0 are different in limits. I mean, there's a difference in talking about the result of a limit and the actual definition of a function. A function approaches infinity, but is never equal to infinity. The function isn't defined where it's infinite, but it does approach infinity. It's the difference between a limit and a function itself. So to be unique, as far as I know, it's not possible unless you want to talk about a numerical solution. Does 1 over 1 over 0 exist? I think as soon as you get something that looks like this, you would say you're dividing by 0, so it's not defined. Or like you'd say this is a bad thing. You maybe can make some argument about like flipping that fraction and multiplying it to get to 0. But I think you already have bad form as soon as you have this, I think. You probably say it does not exist. Am I a math nerd? Yeah. Polynomial p of x satisfies the relation x minus 16. Why do I love math? I don't know. I just think it's cool. Why does anyone love anything? Okay, if x equals 7, what happens here? Chemistry? No. I want to like chemistry, but I just kind of don't. Uh, 16 times 6 is it's a number. It's 96. P powers of 2 equals 0? Thank you, Judd, for confirming. I'm okay, Ahmad. I can be good at math. Yeah, well, when it comes down to it, it's just a lot of practice. That's the unfortunate reality. You just have to grind it out. P of 7 is 135. Oh, I'm sorry, Trish. I didn't see that. You're asking about the physics trick where you say that dy by dx is equal to dy ds times ds dx. I don't actually know when that isn't true. I've seen the trick before, but I never looked into the math justifying it. It's justified based on the chain rule somehow. I don't know exactly. I don't know the exact math of why this trick is a thing, though, unfortunately. Is Gauss law a mathematics rule? I mean, there's like Gauss's law in physics. I think there's also like Gauss's theorem. It's the same as the divergence theorem, but it kind of I don't know exactly what you're trying to get at with that, Ahmad. This trick here, color cone, that's often used in physics. You say that dy by dx is dy by ds dx. Hey, Himanshu, it's just a math help live stream. So I take people's questions from chat and try to solve them. Right now I'm working on number 18. That's right here. And we've got a... Okay, people say it's just chain rule all the time. I don't understand why, or I don't understand how. So I associate that with chain rule. I don't know like what it actually is though. Um, I'm from America. Ahmad, please just put your question once. You don't need to spam it. Um, code to be. I'm not doing that. 32. I already have a full queue of questions. 96, 135 divided by 9. 96 times 135 divided by 9. 1440. Code to be unique. I have a whole queue of questions, people that I've already promised to work on their questions first. I already have enough to fill up the whole stream, or I'm gonna get tired and need to call it. Um, I don't know how you do this question. Favorite mathematician? I don't really have one to be honest. Archimedes is cool, I guess. If I think about India, I don't really have a particular opinion either way. 0 to the 0. We just say it's indeterminate. We don't know what 0 to the 0 is. Please speak English. I need to be able to moderate chat. Um, explain calculus in a simple language. I I have too many questions to work on today already. Designers Den, the designer's den. I'd look up like 3 Blue 1 Brown though. He has a lot of really good videos that do that. That's kind of like too big a question for me to explain, and I have too many to try to do right now. Um, I don't know if that's true, Ahmad, but it doesn't mean that I can understand it. Please just speak English. How do we get P of 11? Vector calculus? Yeah, it's not my best, but I know it a bit. Yes, somewhat like that divergence curl and gradient. Ahmad, English. Yeah, I'm kind of surprised about you because it's not at the streaming is at a terrible time over there, but I guess people are up early. Oh well, good, good luck on your test, code to be. Trig? Yeah, I'm pretty good with trig. For today though, I don't think I'm gonna have time to answer a question if you have one. Where even am I in the queue? Mon and then Yatharth. Usually YouTube chat is slower. Uh, but I would say the behavior is about the same, just usually like not as much of it. Um, Naman? Okay. Thank you for the help on the pronunciation. Sorry for mispronouncing that. Um, yeah, I just don't know how to do this. I can Google it, but I don't know how to do this. Ahmad, next time you don't speak English, it's a timeout. Ahmad, I, I don't have time to take new questions today. I'm sorry because I can't read something that's not English. I don't feel like that should be that hard to understand. They can actually just find P of X. That's interesting. On comments, YouTube actually will translate stuff. I've noticed, but don't seem like that for live chat. I'm from America, Walter. I didn't think about x equals 1 or x equals 16. Interesting. Oh my god. Please no politics either. I don't stream daily. It knows to put x as 1 and 16 because it gives you 0 here and here. So it's actually a really good thing to check that I didn't even think about. I think that Fenmox, that's why you're saying that power to 2 would give you 0, potentially. How does it give a 0 though? Just literally take x equals 1 or x equals 16 in this original equation. Like if you let x equal 16 here, you would get 0 times p of 32 equals 16 times 15 p of 16. And so you just get 0 equals p of 16. I already have a bachelor's in math. I graduated like 7 years ago. Now once you do this thing with g of x, you can find that you can find two more zeros at 4 and 8. H of 2x equals h of x, so h of x is a constant. That's crazy. I don't really know JE Advanced. Those questions are kind of insanely difficult. Okay, I'm gonna link the stack exchange thread into the YouTube chat. In case it helps you to have that in the mun. I'm gonna pick up where they leave off though. 2, 4, 8, 16 in a constant. Ah. Hey, Dessen. I'm just a tutor. Oh, then you can use the initial condition, p of 7 equals 135, to actually find it. Because once they got to h of x in that stack exchange thread, they basically found that after a certain level, h of x is equal to h of 2x, and that can only be true if it's a constant. Or adds. You can't deal with a tiny amount of ads and then you don't have ads for the entire rest of the stream. um 135 minus 5 minus 3 minus 1 minus 9. Hundred thirty-five C 45. No, not 45 times 3, right? Oh, isn't it just 135? Okay, yeah. So C is just 1? Huh. Okay, so then P of 11. Deep concept questions, ISI, CMI. I want light concept questions. I want easy. Ugh. People love asking me really difficult questions, and I want to do questions that I actually know how to do. That's a job for a calculator. 9753. 9735. 9735. 945. C. Sum of the roots. 6, 14, 30. Product of the roots. Um, 1, 2, 3, 4. Why can't I do that in my head? 10. So 4 to the 5th? A. There we go. Uh, 6. It's because I was adding up 2 plus 4 plus 8 plus 16 to answer part B. Or part 2. Hey, Ren. What's the queue like right now? In theory, you can put questions just there in chat or in my Discord. I have to get through at least one other question right now. Okay, yeah, Tharth, I'm not sure if you're still here, but we can work on your differential equation. I'm just going to look at the thing that I wrote on the left here because I'm more familiar with it, but I think these two differential equations are the same. Y double prime plus y equals cosine 2x. Oh, sorry, and you asked a question about Chinese exam maths? Probably not. Oh yeah, sorry. If you're asking me about social media, I just had the Discord server, and that's basically it. Naman? Yeah, sorry, I wasn't doing a good job of explaining it, but I would just use that Stack Exchange thread, and then the rest kind of follows directly from it. Sounds good, Femlux. Uh, 8 Vega 8, thank you for the follow. 25. 25 factorial. Okay, so the first thing to do here is to get the homogeneous solution. And so we do that by solving the differential equation y double prime plus y equals 0. And for this, we can just use a characteristic equation. The characteristic equation will come out to be this, which doesn't factor. Math, hell yeah. Whenever I see a new person, I like to let them know that a math niche exists on Twitch. So I'm not sure if you're already familiar with it, but just in case, I'm not the only one who streams about math. There's a whole list of people who do math help in some way there, and you just like keep an eye on the math category on Twitch. There's even more people than just that. Oh, and someone who's not on the list is Academy Useless Ideas, who's just hanging out here before. Should give him a shout out for saying the math zone. Oh, nice. So yeah, no obligation to like go and like follow a million people who I just like link, but if you do, if you're super enthusiastic about it, please feel free to do that too. But yeah, there's a really cool like niche here. People who just enjoy math and want to talk about math. There's even like math classes that get taught on Twitch. No worries, Slim. So yeah, no matter like what your interest is, there'll be someone doing something. Hey, famous. Oh yeah, hey, yeah. So like, there isn't always someone who's streaming the math category, but like, that's where a lot of us tend to stream. Wants to know more math? Yeah. Well, welcome in. You don't have to if you want. Feel free to like share your background or what your interest is or anything like that. Okay. So we need to solve this characteristic polynomial. I guess we need the quadratic formula here. Isn't this the golden ratio? No, the golden ratio polynomial has minuses, right? -1 plus or minus square root b squared minus 4ac over 2a. Do you code? I'm not sure if you're asking that to me or to someone else code, but I do code a little bit. And oh, you're okay. Sorry, I'll just assume that you're talking to Trium back then. Times tables, additions, take away an addition. Hey, that's still math right there. No shame. Okay, and then how does can I just remember what the formula is for this? It's gonna be e to the real part t. Oh, we're using x here. Oh, imagine using x for a differential equation. Constant times a cosine of the imaginary part x I don't know how to spell homogeneous. There we go. I still don't have enough room. Plus c2 sine root 3 over 2x. I think that's the homogeneous solution. Let's use chi instead. True, Jed. That would be more exciting. Okay, so that is the homogeneous solution. The particular solution, Obi suggested using undetermined coefficients. But we can, yeah. There's no reason we can't use a smiley face for a variable. So I think for undetermined coefficients, you make a very educated guess. And so on the right side, we have cosine of 2x. Is it just going to be a cosine x, or do we need to also include a sine x? We probably need a sine x, right? No, maybe it's just cosine. I don't remember that. Obi's saying, okay, yeah, we do need a sine x. Thank you. So yeah, you can just guess what the particular solution is based off the form of the, I think it's usually called a forcing function. Because in like a circuit, that would be like your source of voltage or something. So we'll take the particular solution equal to a cosine 2x plus b sine 2x. Oh, Edison. No worries. Thank you for checking back in. If you have any questions, feel free to let me know about it. If I missed anyone else in the YouTube chat, it's not intentional. I don't think I did though. Or if I missed anyone in any chat, it's not intentional. Okay. And so now the goal is going to be to take a particular solution and plug it back into the original thing, because the only thing we need to do is figure out what A and B are. We already have the form of the particular solution here with our good guess. So we to figure out what A and B are, we plug it back into the original differential equation. But of course, we can't do that unless we figure out what y prime and y double prime are. So let's do that. I need to change places. Yp prime. So take the derivative of this thing, we get minus 2a sine 2x plus 2b near automata reference sine 2x. Now do the cosine. As to focus on making a stupid reference. Take the derivative again. Minus 4a cosine x 2x minus 4b sine 2x. Okay, now we can plug all this stuff in. So y double prime, plug in what we just got. Cosine 2x minus 4b sine 2x. Plus y prime, so minus 2a sine 2x plus 2b cosine 2x plus y plus a cosine 2x plus b sine 2x is equal to cosine 2x. Ooh, the red. I can see just in the corners of my eyes. Okay, so now we solve this for a and b. It looks weird. It is weird. But the thing that we can do here is equate coefficients. So we can take all of the cosines and isolate them into their own equation, and take all the sines and isolate them into their own equation. So taking out the cosines, 4a cosine 2x. We have a 2b cosine 2x. A cosine 2x is equal to cosine 2x. Two variables, one equation? Yeah, Rin, but we can still deal with this. This is a trick called equating coefficients. We know that cosine of x and sine of x aren't usually 0, or at least we don't care about when they are 0. It's not like, we would call that trivial. So the only way for this equation to be true is if everything in front of the cosines, like everything on the left side of the cosines here, should add up to be whatever's on the right side of the cosines. Same with the sines, we can pretend we have a plus 0 sine 2x here. And so that's a trick that we're using here. Like the coefficients in front of the sines and the cosines should match. 2a sine 2x plus b sine 2x equals 0. Badar, thank you so much for the kind words. Hope you have a good day. Okay, and so now, like I said before, sine and cosine aren't usually 0. Is, you know, if they are 0, we call that trivial. We're interested in solutions of a and b that make this thing true. So I'm going to divide out the cosines from the first equation. and divide out the signs from the second equation. And now we have two equations, two unknowns, and we can solve this. Let's group some common terms. Minus 2a minus 3b equals 0. Okay. The second equation looks simpler, so let's start with that one. A is equal to 3 over 2b. Plug it into this first one. 9 over 2b equals, or plus 2b equals 1. Yep. Combine a minus 5 over 2b equals 1. Okay, yeah. So b is minus 2 over 5. Which means a, going back to this relationship, is minus 3 over 5? Do I know how to do math? Yeah, okay. So that means, and we know a and b, so we know what the particular solution is. A goes with cosine, so that means the particular solution is minus 3/5 cosine 2x plus, well, b, but b is negative 2/5 sine 2x. So at the end of the day, the solution to the equation is homogeneous plus particular. Piyush, ask once. Just ask your question. Stop spamming. Oh my god. You could ask your question because you spammed. You're in timeout for a minute. Oh my god. Limits in a nutshell. Thank you for posting it once, by the way. Do I have a queue still? Is this the last one in queue? Yes, I can. I'm just wrapping up this question and then I'm through the queue. Oh wait, and Felix, you have your differential equation, right? Feel free to put that. The answer to the question is the homogeneous that we found before plus the particular. An important thing to remember is that the homogeneous has arbitrary constants. Any linear combination of them works. The particular does not. It's only that one. It's particular. Thank you, Vega. I don't just do like complicated math that a lot of people haven't seen, but before I'm happy to do any level of math. But this person hasn't happened to ask me something that would like come after. It's called differential equations, which like comes after a calculus class. Hey, Lucas. Yeah, if you're just a genius like Lucas, there isn't really such a thing as a hard question. But for the rest of us, you know, I know you're joking. Um, Ooh, interesting. Okay, so I want to explain to Kushal what a limit is first, but that question does look neat. Oh shoot, Rin, you asked a question too. Oh, I didn't put you in queue. That's my bad. Um, okay. We need to do Rin's first, because Rin has been here for a while. Dang it. I want to try your question in box, but I want to. I don't know. I'm gonna have to put you back in queue a little bit. I do want to do yours though. Okay, we're doing Rin from the Discord, and then it's oh my god, I can't spell. Wants to explain limits, which I'll try and do relatively quickly. And Obi might just be able to solve it right there. Three, 6, 9, 12. Isn't that just 15 p-ish? We're just adding 3 each time? No, guys, don't make fun of p-ish. That's an honest question. Like, assuming that it looks like an honest question, like, don't... No shaming. Piyush, in that pattern, it looks like they're just adding 3 each time, and so I think the way to fill in that gap is you do 12 plus 3 is 15. What's in that gap? College math? Depending on like a first year or so, yeah. No, I mean there's no such thing as an easy question. We all start somewhere. What's up with this question here? Positive integer n. I hope again we can find that pattern, Lucas. There's many answers. $20? Yeah, I mean, you could say 20. You could say basically any number you want, probably. This is finite? How is this finite? 8 is your favorite number? That's not a bad choice. Doesn't exist? Oh, okay. I don't have too much of a favorite number. You know, I'm just gonna say it's 1. Tree. So yeah, I'm kind of like, yeah, Kushal. I have the exact same thought, like infinite, finite, 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 finite. I don't see how this is. I don't see why we don't have an infinity option. Everyone likes pi? Well, yeah, but if everyone likes pi, then I feel like it's a crappy choice for favorite number, you know? You should be unique. There's only one choice for your favorite number. And it's 1. Discrete math? I'm not very good at discrete math. 0? Nah, not 0. 0's a jerk. I don't really see it. What is the pattern in these anyway? I can sort of see a pattern with this progression, but also not really. Some of these terms do fit nicely into patterns, others don't. 0's a jerk? That's controversial. Well, you can't divide by it, Multiplying by it makes things weird. It's a nice round number. 8 is doubly as round. It's a baby number, not an adult yet. Factor? I'll fight over the best numbers. 8 is roundest and best. You're in class 11th? Oh, nice. P-ish. How do like logs come into this? I'm so confused by this. Do you already know how to do this? I don't see what the general form is supposed to be. Three is half of 8? I think 4 is half of 8. Humor is 3 since it's the first. Or that isn't different from the rest. Fair enough, Lucas. Oh, in a reflective kind of way. Yeah. If you mirror 3, you get an A. Yeah. 53. Oh, yeah, fair enough. Kushal. What the hell? How are you supposed to see this? These apparently have. I wonder if you could do this without whatever this crap is. Here, I'll put this link in the YouTube chat in case you want to like look at this for yourself. I would not have gotten this on my own though. This is crazy. Why would you like ever do this? I assume you could do this the old-fashioned way with some like polynomial long division and theoretically find things that I would add up to the minus n term that you need. I would be able to do this on my own. Yeah, this is pretty pointless math. I would say. I don't know why you would ever need to use this technique for anything. 12th graders have to do this. I think it's stupid that a student has to do this. So yeah, I'm sorry, I can't really even explain this all that well, but it looks like that's something there for you to go off of. I'm from America. And so yeah, for parents New Year, I do dual stream to Twitch and YouTube. The chat that's up there is just the Twitch chat because I can't put both chats there at once. But if you hear me talking to someone who's not there, then that's why. Okay, I'm gonna move on from this one because it's annoying. Math symbols. Okay, so Kushal wants me to explain limits. Hey, Carrie Hunt. It's intimidating to me too. I'm right there with you. You think between bound stages there's... Oh, yeah. I can kind of see that, Lucas. Okay, so Kushal, just like explanation of what limits are. Um, Let me start off with the boring case for what a limit is. Or like, the kind of clear case, maybe I should say. If I just have a parabola, y equals x squared, and we're interested in the limit as please speak English. Has something to do with domain? In a way, yeah, it gets into the idea of domain a bit. A limit, kind of in this relatively simple case, let's just look at limit as x approaches 2. So we're limited to the limit right at this point. What we do is we think about how the function behaves leading up to that point from both directions, like from below and from above. And we don't care about what the function, well, we do care, but the function doesn't always have to even be defined here at this point. Here it is, because I said this is the nice case that's a little bit boring. So we kind of note this as limit as x approaches 2 of x squared. And so here the limit is just whatever the value of the function is. Like it's just going to 4 because that's what 2 squared is. So the limit describes how a function behaves at a certain point. I'm a tutor, Piyush. Now, a little bit more of an exciting case is well, there's a couple different directions I could go here. I guess, okay, let me look at a weirder function. Let's look at yeah, exactly, Kushal. There you just kind of plug in 2 and not worry about it. In other cases, you do have to kind of worry about that sense of direction. So let me actually, instead of what I was going to do, let me define a function that's piecewise. Let's say y is equal to -1 when x is less than 0 and +1 when x is greater than or equal to 0. This function will look like that down below and this up above. All right, so if I ask you about the limit for any point kind of off to the right here, we would just say it's 1. That's just the function is like, it's clean there. Same thing if we go off to the left, it's going to be -1. The spot where this gets interesting is what if I ask you about the limit as x goes to 0 of this function y? We run into an issue because from the left of 0, we're going to -1, and from the right of 0, we're going to +1. And that's kind of, those are just 2 separate numbers that we can't just choose one. It's behaving in 2 different ways on different sides of 0. And so here, because we can't say just one clean number, we would say the limit does not exist, or we abbreviate it to DNE. So like both sides have to agree in order for the limit to exist. And so what we can say instead, we can talk about this left and right-handed limits. So we can say the limit as x goes to 0, and then we do a little plus, meaning from the right. Not defined exactly. And so if you do that little plus there, it means from the right. And so we can talk about just that green arrow up there. And say that from the right, it goes to 1. And we can do from the left a little minus sign and look just at that part down there and say -1. And so if these two limits agree with each other, then the overall limit should exist, and the opposite is true. If the two left and right-handed limits don't agree, then the overall limit does not exist. Let me give you a third example. You might remember with like rational functions, removable discontinuities. Like maybe you could end up with a graph that looks something like, let's just say that's at the point x equals 3. Some function looks like that without trying to actually say what it actually is. No worries, Carrie. Thanks for hanging out. And so right here we have a little gap at x equals 3. And so the function isn't defined at 3. Actually here, I can actually I can name this function. Y equals x minus 3 over x times x minus 3. It's one of those functions where I could cancel the x minus 3, but we're still allowed to have x equals 3. In this case, we can still take the limit as x approaches 3, and it's still fine. The cool part about limits is it doesn't care if the function is actually defined there. It just cares how the function behaves around it. So this limit still works, even though x can't equal 3. It's just going around 3. So we'd say it's 1/3 here. Okay, and you're asking the other tricky thing, which is if we want x to approach 0. So this one looks weird for approaching 0. So let's look at the left and right-handed limits. If we approach 0 from the right, we're blowing up to positive infinity. So limits can result in infinity, or like, I would normally say equals infinity. In other classes, they might tell you to say does not exist or something. But to my recollection, like my person would want us to write like infinity there. Hey Phobos. But then the thing is on the left-hand side, we're kind of blowing up, but to negative infinity. We're going all the way down. And so the same thing here, these left and right-handed limits don't agree. One's getting to be a very big positive number, the other one's a very big negative number. So those don't match, so we say the overall limit does not exist. I think it's okay to just say limit equals infinity. That is different from not existing. No, I have a bachelor's in math, but I'm not an actual like teacher. Can we guy lim on y? Put lim on y. Yeah, I mean, I'm using that as a shorthand. Or wait, are we asking like a limit as y approaches something? Like a limit like as y approaches 2 or something? You could take like the inverse of the function and take the limit of that. That would basically be the same thing. Um, Normally you don't take limits with your output though. You do a limit with your input and see what the output is. It's kind of backwards. It makes me very uncomfortable to do that. With normal limit definitions, it doesn't really make sense to take y to a limit. You might be able to make some definition that does make sense, but with kind of how things are normally done, I would say it doesn't really make sense and it's potentially not very useful. Um, yeah, and so I think there you're okay, Kushal. Yeah, I think you can get into weirdness if a function isn't invertible. Um, but if it's invertible, you could invert it and do the limit like that, and that'd be okay. Yeah, I guess that's what I have to say for like a little introduction on limits. I hope that helps. Hey, Jesu. Hey, it's G1. Okay. I think we might wrap up the day with Fembox's differential equation. Wow, we're at 16 pages here. First, like 6 or 7, maybe are just like uh not related to today, but Lightning Leon. It's a nice username. Thank you for the follow. Nobody dare make a dad joke called me back. It did cross my mind. um Astronomy show. uh, I'm sure you do. Hope you're doing well. It's always nice to see you. If anyone's interested in space stuff, please do check him out. Great stream over there. Maybe front. No worries. I am sorry. It's gonna be the last question of the day. I think I've been going for nearly 4 hours. My brain can only handle so much thinking. Um, can we torture this until it's separated? I don't think so. It's probably not separable. So how can we do this? Is it exact? It could be exact. That's probably not exact. We should check it though. How do exact differential equations work? We need, yeah, it's always the reverse. Um, the partial of that in y should equal the partial of that in x, and they sure don't. Okay. I put the equation back up here. I assume you're not interested in like a Newton's method. That would feel bad. Or like a numerical method. You was like anything? No, I'm not gonna do a numerical method. Plus, the derivative isn't defined at 0, 0. Or as I don't think it is. And I don't know how you deal with that. I I'm live on Twitch as well. That's the chat that's up there. I would show the YouTube chat too, but I actually can't. Um, SG1, I'm not gonna have the brain, or I don't like JE advanced questions, and I'm definitely not gonna have the brain power today. Hmm. Where did you get this from? Do we know it's solvable? Obi said something about this before, right? Let me bring up the chat logs. dy by dx equals f of x y. Start there. You have your sources up. Okay, that's fair. Obi said to start by isolating dy by dx. I don't know how math works. Hey, Piyush. Good luck, Kushal. It looks like a really tough exam. There's no exponent. Oh, why did I put that there? Oh, is it exact? Oh, this is exact. Um, I sabotaged it. You take the partial of that with y, the partial of that with x. Yeah, it's exact. Oh my god, how did I put the squared there? Uh, okay, I'm sorry, Lucas. I saw it, but I didn't respond to it. Do you know what these? I'm not sure what you're doing there. I think you're misunderstanding what this. I suppose that you haven't learned differential equations yet. If you could solve this, it will be that'd be pretty like genius of you, since I don't think you've seen it yet. Yeah, just inserting that one exponent made it completely different. I'm sorry, Piyush. I won't be able to solve that. I'm I'm relying on Paul here. So with the differential equation, you're solving for a function. You're not solving for a number. That's the thing that makes it weird. Okay, so we can choose either one we want. Psi sub x. Psi sub x is equal to minus y, we would say. So then psi, we'd integrate that with x to get minus yx plus some function in y. And then we take the derivative of y, that thing, minus x plus h prime y, and set it equal to that, right? That's how this works. The x's should be canceling here, shouldn't they? Why are they not canceling? Hey, here's Axel. I'm not sure. I'm pretty sure this thing is just exact, and I want to solve it that way. Um, I've already done something wrong though with. All right, see you soon, Lucas. With the x's, they're supposed to cancel. And they are not canceling. Oh, you're right. That's why they're not canceling. It's not exact. Oh my god. I checked when it was exact when the y was on this side, and then I subtracted it over, and it was like, oh wait, that makes it not exact. Um, sorry. I'm just a tutor, P-ish. I'm not a teacher. Um, okay, Fierce Axel was saying to find an integrating factor. Let's see what it would be though. I'm not very good with integrating factors, to be honest. I really should be. Okay, I should just learn how these things work. How I should think of this question. Basically, name a function whose derivative equals this. Okay, there's now been two. I mean, I never used this before for differential equation. People are saying to think about it in terms of dx dy. Looks like that's what Jasu did also. Um. Oh, I guess it is linear, isn't it? Like that. Hmm. It's barely not exact, Obi. If you subtract the y over to the other side, you get like 1 and -1. Yeah, I've learned a solve differential equation that's like this. I just what I haven't learned is the trick of reversing x and y. The integrating factor is 1 over y. Oops. So then x. Wait. Not magic. This is the last quick question of the day. If you want to put it in my Discord, and I can try and get back to you another time, but I'm wrapping the stream up after this. One over y times 2y squared dy. And I like to add in the integrating factor right now. What's your question, non-magic? I don't have another way. It should be x over y. I don't have a telegram. P and C? Permutation combinations? No, not really. I don't see what it should be x over y. Binomial? I like a question about binomial. Obi-Wan Benson and the Jinko are the same. Yeah, the initial conditions still seem like it. I mean, Jess is just getting a cubic. That will be fine. I have heard of JE Advanced, and I'm terrible at those questions. Okay, I'm getting a different answer than Jasu, which is scary. I would believe it's the most difficult one. It's incorrect. I believe it. I don't know what I did wrong, though. My integrating factor is 1 over y. Wonder I should be on the other side? Oh my gosh. You divide by it. Ah. Yeah, it should be like that. That's my bad. So yeah, y cubed plus cy. Okay, nice. Rin, you need to stop. You can say things in a nice way too, Rin. The thing is, the initial condition still isn't too helpful, right? We can't, it's not a good enough condition to solve for C. That's so weird. Uh, it's because of the way that the condition is set up. Like, it always goes through 0, 0, no matter what C is. Yeah, the initial condition is like entirely unhelpful. Like you could look at this and just always know 0, 0 is a solution without like initial condition is just like redundant information. It hasn't narrowed down. The family of solutions. Yeah, like no matter what that C is, it's always going to go through 0, 0 anyway. So I don't think we have a real initial condition. Does this question for X satisfy the DE? Uh, check it. How do we check it? Can we invert this? Oh, wait, okay, yeah, we don't invert it. We can say that it's equal to x plus 2y cubed over y, or we can check that. And we know that x is equal to that. Okay, it looks like it checks out. The initial condition, like, it's like a well, duh initial condition, I guess. Like, it doesn't actually narrow things. It's true, but it doesn't actually narrow things down. So I don't think this is, it's not physically solvable. After this point, I don't think. Because there's just literally multiple, there's infinitely many possibilities for C even with that. Bernoulli differential equations, I've seen them before. I probably solved them like once or twice. Oh, I'd never seen this website but before. These are puzzles. Hmm. Person posted tons of problem here. Sorry, Rin. I'm not gonna do it though. It seems like there's a just an error in the problem. I don't know. It's just not possible, as far as I can tell. Like I was wondering if x equals 2 would always have one solution regardless of C, but I don't think that's true. I mean, the solutions are already like what I got in Desmos. We don't even need a slope field, I don't think. Oh, there's potentially multiple values when x equals 2. You gotta assume that it flattens out for large values of A. Oh, like yeah. Yeah, hey, Gov, are you familiar with quantum mechanics or Hilbert spaces? I am not. Um, Quantum mechanics. I know that Fred studies a lot of quantum mechanics on his stream. Um, if you're asking about like, or maybe Jasu might know something. Like a Hilbert space, I don't know if that has like a physics thing too. I feel like I've heard like Zach might know a little bit about Hilbert spaces in terms of like math. But I don't know anything about either of them. Okay, yeah. Then and I guess the only person I can really think of is Fred. I mean, you might be able to try physics in depression too. Um, I don't know whether he knows about it or not. Yeah, but yeah, I mean, try describing your problem to Jasu. Okay, yeah, we are violating uniqueness, Fembox. No, I mean, I no worries. Um, I think it's just a bad problem. Oh, Cook is back. Are gonna talk about waffle stomping some more? Yeah, that is a neat realization. Um, I want to wrap things up, but if Jasu is typing something, I don't want to cut Jasu off. Um, yeah, Gav, I'm trying to think of something about like quantum mechanics and Hilbert spaces. You're not okay. Just so you were asking Gov for more information. I wasn't sure if you were gonna try and take that on. Um, yeah, you can try predator physics and depression. I can't really think of anyone else who like puts themselves out there to do help that might know about it. Yeah, sorry. Good luck with it. Um, okay, in that case, I think. Oh, and thank you for the follow. Um, I think it is time to wrap things up then. So I'm gonna cut the YouTube stream off here. So people here on YouTube, thanks for being here. I'll be back on Saturday in 2 days. The first 2 hours though are going to be a reading group for general relativity. I won't be doing math help at first, so just a warning. But yeah, I'll see you YouTube folk. My Discord. I've been saying over and over again. This is the last question I'm doing today. Are you supposing that? Like, I don't think you need help with that question either. I feel like you're just quizzing me with that. If you do actually need help, please like let me know in the Discord thread. But the impression what I'm getting from what you're saying is that you're just giving me questions to work on, and that's not that's not what I'm here for. Um. So yeah, I'll see you later, YouTube.